Hi everyone, welcome to another one of my quick explanation videos. Today I'm going to talk you through nuclear radiation very briefly and talk to you about the different characteristics of the three types of nuclear radiation and talk you through the diagram explaining how we can tell the difference between the three of them with a simple experiment. So nuclear radiation is different from the electromagnetic radiation you studied last year. Electromagnetic radiation comes from the electrons around the outside of an atom, but nuclear radiation comes right from the nucleus of an atom. So there are three types of nuclear radiation. There's alpha, beta, and there is gamma. Now you might have heard of gamma radiation before. You might have heard of that last year because gamma doesn't always come from the nucleus. Sometimes it comes from the electrons, so it's an electromagnetic radiation. It's both sorts. Now, we worry about the ionizing potential of nuclear radiations. All of them are ionizing, and alpha is the highest of those. I mean, you don't need to worry too much. It's all about comparing them to each other. So alpha is the highest, beta is sort of in the middle, and gamma is the lowest. But they have the opposite pattern when it comes to their penetrating potential. So this is how far through materials that they can travel. So alpha is the lowest, beta is again in the middle, and gamma is the highest. And it's also quite useful to consider how far these types of radiation travel through the air. So alpha will only travel maybe a few centimeters, beta will travel a few meters, and gamma will travel nearly infinite. Infinite being, of course, an unlimited amount of distance. So there's your three properties. Let's talk now about this experiment down here and what we can do to tell which one is which. So alpha radiation is a helium nucleus. It's not helium because helium has two electrons around the outside. It's just the inside of a helium atom. It's the helium nucleus. A beta particle is an electron. The exam board likes you to know that it's a fast or high energy electron. And this last one down here, this is a gamma. It's not actually a particle at all. That's what this wiggle is about. This is a high energy wave. Okay, so as you can see, the alpha isn't coming through the paper because its penetrating power is so low, it doesn't come through the paper. The beta is a little bit more penetrating, so it's able to travel through the paper, and it's stopped by sort of a thickish aluminium foil, so maybe 1 or 2 millimeters of aluminium, I should say. And then lastly, you've got gamma. Now, as you can see, gamma penetrates easily through the paper. It's not affected by the aluminium either. Its intensity, the amount of it, is reduced by thick lead. So if you want to almost completely stop gamma radiation, you'd need several centimeters, maybe more, of lead. The other thing we say sometimes is that gamma is stopped by thick concrete. So the helium nucleus is very large, it's very ionizing, but it doesn't travel very far, and it doesn't travel through very much either. Beta radiation is slightly less ionizing, but that means it can travel a little bit further, so it will go through the paper and it's stopped by aluminium. And lastly, gamma, which is not particularly ionizing, it's got a very low ionizing potential, will travel through the paper, the aluminium, and through the lead. Okay, it's reduced by thick lead. I hope that's been useful for you today. If you've got any extra questions or suggestions for what you'd like a video on, pop them in the comments below. Thank you very much. Thanks for watching.